Hello, welcome to Tennessee's At-Home Learning Series for Math. This lesson is for all our 8th graders out there, though all students are welcome to tune in. This lesson is the 15th in our series. My name is Candace Thompson, and I'm an 8th grade math teacher at Oakland Middle School in the Rutherford County School System. I'm so excited to be your teacher for this lesson today. Welcome to my virtual classroom. If you didn't see our previous lesson, you can find it on the Tennessee Department of Education's website that I have pulled up here. If you will scroll all the way down to Math Grade 8, you can find our lesson plan and the teacher lesson plan link and the student packet with the independent practice on the student packet link. Today we'll be continuing learning about systems of linear equations, and we will be working on estimating solutions by graphing. Before we get started, to participate fully in our lesson today, you will need the following: paper and a pencil and a surface to write on. A calculator is not required, but may be used to check your calculations. Optional but helpful materials would be a straight edge and graph paper for the student practice worksheet today, which includes a cumulative review of our lessons on solving systems of linear equations. Okay, let's begin. We're finishing up week 3 of our 8th graders with mathematics learning series, and we are still working with equations and expressions this week. Let's warm up with a little practice. So in lesson 14, we looked at the following chart, and this chart told us about the maximum heart rates based on each person's age. Remember that X represents the age of a person and Y represents the maximum heart rate. Here's what we wrote in our previous lessons. Y equals 220 minus X. Now, let's write and simplify an expression that gives the person who is X years old, or that gives the heart rate that is 70% of the maximum heart rate for a person who is X years old. Think about how we would modify the equation. If we want to represent 70% of the maximum heart rate, we can write the equation this way. Y equals 70 times 200 minus X. How would we change this function to solve for the person's age, X? Think about that for a minute and see what you can come up with. See if you can follow my steps. So we have a Y equals 70% of 220 minus X, which gives me 154 minus 0.70X. So then I'm going to subtract 54 and 0.70. And so I'm left with Y over negative 0.70 plus 220 equals X. Now we could clean this up a little bit, but for now we are good to go. This equation now gives us the person's age X as a function of the maximum heart rate Y. Give it a try. The person's maximum heart rate is 121.1. What is their age? So we would plug in 121.1 here. Did you get 47? Great warm-up. Now let's get started with today's focus. Now in lesson 14, we looked at ways of solving linear equations by the elimination method. We chose one variable to eliminate. We needed the variable to have the opposite coefficients, and then we could add the equations together to solve them in one variable. That's the same thing we need today. So let's just practice finding some common multiples to help us when a system of linear equations looks like this. You can grab your paper and pencil and write the system along with me. Now, what do you notice about this system and the coefficients of the X terms and the Y terms? So you probably noticed that 2x and negative 3x could not be eliminated in this system, just as they are by either addition or subtraction, because they don't have the same or the opposite coefficients. So how could we use the multiplication property of equality to transform these equations so that the coefficients x have the same or opposite coefficients? Now remember that the multiplication property of equality tells us that if we multiply every term in an equation by the same term, the resulting equation is equivalent to the original. So let's look at the coefficients of the x term. In this case, we want to think about what is a common multiple of 2 and 3. There are several to choose from that would work. See if you can come up with at least 2 common multiples of 2 and 3. Write them down on your paper. Did you come up with any of these numbers as common multiples? We've got 6, we've got 12, and we've got 18. Great. Now let's look at the coefficients of the y terms, which are -3 and 5. Think for a minute about finding a common multiple of 3 and 5 and try to come up with at least 2 different ones and make your list on your paper. Did you come up with at least 2 of these? We have 15, 30, and 45. Great. Let's move on to using this skill to help us solve the systems of linear equations using multiplication. Let's go back to our system of equations that we looked at to start with. Remember that we can choose to eliminate either the x terms or the y terms, but we will need to transform these equations by multiplication so that one set of the terms have opposite coefficients. For this example, I'm going to choose to eliminate x. I know from before that 6 is a common multiple of 2 and 3. So in this case, I know that I can multiply by 2 and 3 and get 6. Or I can multiply 2 by 3 to get 6, and I can multiply 3 by 2 to get 6. So let's do that. So I'm going to multiply this top equation by 3, and I'm going to multiply this bottom equation by 2, and that's going to change both of these to 6. So when we multiply each equation, don't forget to multiply every single term to preserve the equivalency of the transformed equations to the originals. All right, so when I multiply, I get 6x minus 9y equals 12, and then I get negative 6x plus 10y equals negative 6. Now we are ready to simply add the equations together like we did in lesson 14, since the coefficients of one of the terms, in this case the x term, are opposites. So we're going to add these, and these are going to be eliminated, and that leaves me with positive 1y equals 6. Now that the x terms are eliminated, we come up with y equals 6, meaning that the value of y of the solution ordered pair is 6. Now to find the value of x in the solution ordered pair, simply choose one of the equations, whether it's one of these original ones or if it's one of the transformed equivalent equations. I'll choose the first equation in the original set and substitute the value of y in the equation to find x. Follow along with me. So I'm going to use this top equation here, and I have 2x minus 3 times 6 equals 4. I have 2x minus 18 equals 4, which gives me 2x equals 22 and x equals 11. So we can say that the solution of this system of equations, if the ordered pair, is 11, 6. Let's try another one. Let's look at this system. You write it along with me. Okay, looking at the x terms and the y terms, what are the common multiples of each set? Right. In this case, the coefficients of the x terms are 1 and 3. And some of the common multiples are 3, 6, or 9. The coefficients of the y terms are -5 and 2, and some of the common multiples would be 10 or 20. Remember, you can choose which variable you want to eliminate. I'm going to choose to eliminate the y term in this case because they're already opposite signs. I'll use 10 as my common multiple. Follow along with me. So here is my original equation. I'm going to multiply this top by 2 and the bottom by 5 so that my y coefficients can be the same. So when I do that, I have 6x minus 10y equals -18, and I have 5x plus 10y equals 40. Okay, so now they're opposite, so it's the same number but opposite sign, so I can use addition to eliminate the y variable. So when I do, I'm left with 1x equals 22. Since the x terms in the solution ordered pair is equal to 22, we just choose an equation to substitute that value back in to find the value of the y terms in the solution ordered pair. I'll choose the second original equation this time just to show you that it doesn't matter which equation I choose. Just remember that you can choose any of the equations in this system, either the original system or the transformed equivalent system. Okay, so I have x plus 2y equals 8. That's the equation I'm using. I'm going to plug in 22 for x. Okay, when I do that, I'm going to have 2y equals -14 and y equals -7. So we can say that the solution of this system of equations, if the ordered pair, 22, -7. All right, guys, great work today. After this lesson, you'll have a few problems to practice on your own. I will show you the independent practice problems now, which I've shown you at the beginning. Just scroll all the way down to Math Grade 8 and click on the student packet to access those. Good luck and do your best. Thank you so much for inviting me into your home. I look forward to seeing you in our next Tennessee's at Home Learning series. Goodbye.